This is trigonometry lesson. This is another Greek letter called theta. In science and engineering, we use it for an unknown angle. Here is theta as the unknown angle in a right triangle. Right triangle means 90 degrees, and we put a little square there. And opposite theta is the opposite side, and the long side of the right triangle is called the hypotenuse, and we call this side the adjacent side because it is adjacent to the opposite side of the unknown angle theta. Theta is also the unknown angle in this similar triangle, and in this triangle as well, the black one. If the opposite sides are as shown, 3 for the red, 6 units for the blue, 9 for black, and suppose the adjacent side for the red triangle is 4, then I know if these triangles are similar, these adjacent sides for the blue and the black. Adjacent side for blue is 8, adjacent side for black is 12. If the hypotenuse for the red triangle is 5, then the hypotenuse for the blue triangle will be 10, and for the larger black triangle, the hypotenuse will be 15. I'll summarize the sides in this way. Let's talk about the ratio of sides for these similar triangles. For the red, blue, and black triangles, here are the ratios of their opposite sides over their hypotenuse sides. Notice these are all reduced to the same ratio, and the decimal form is 0.6 for all of these. Here are the ratios of the adjacent side over the hypotenuse sides for all three triangles. These all reduced to the same, and it's 0.8 in value. And finally, the opposite sides over the adjacent sides are these ratios, which are all equivalent to this decimal. So whatever this angle theta is, no matter what triangle it's in, the ratio of its sides is going to be the same. It doesn't matter if it's smaller than the red triangle or bigger than the black triangle. The ratio of its sides that are shown here are always going to be equal to these. So what this means is if the angle, and we're calling the angle theta, of a right triangle is known, the ratio of its sides is also known, and we use that to our advantage in math and science. And also the converse is true. If a ratio of sides is known for a right triangle, the angle is known. Here is a trig table that shows angles every half degree, and then the ratio of sines, cosines, and tangents. Sine being defined as opposite over hypotenuse, cosine as adjacent over hypotenuse, and tangent as adjacent over opposite. So we see for a 10-degree angle, the ratio of the sides of any triangle with a 10-degree angle is going to be 0.174. That's opposite over hypotenuse ratio. Adjacent over hypotenuse ratio, which is the cosine, is 0.985. And opposite over adjacent ratio will be 0.176, and that's the tangent. That's for any triangle with the angle of 10 degrees in it. And we know that for any angle, because all the angles are on this table. And this table can also be used this way. Let's say you know the cosine of a certain angle is 0.5. Well, you can use this table to say, well, that angle must be 60 degrees. Now, we have this table to use as a reference. Your calculators also have these values stored in them. You can do sine, cosine, and tangent. Using it this way, this would actually be inverse cosine function. So whatever angle, in this case, the angle is 60 degrees. So the inverse cosine of 60 degrees equals 0.50. So if you were to use those keystrokes on your calculator, the calculator would give you that. We'll be using this table to get started.